Hello everyone, welcome to this new kind of video. So during JOSAA counseling, I have noticed that many students make their decisions regarding the various choices for the departments based either on guesswork or from hearsay or some bits of scattered information, which is not really helpful. So I thought it would be a nice idea if we can get some proper, comprehensive, reliable information from proper, reliable sources regarding the various departments. I myself wish we had this kind of an information when we were students, but it is what it is. What better source to have than the professors of the various departments? So in the first of these kinds of videos, we are going to have a broad discussion with a faculty member of aerospace engineering. He's Professor Sunil Manohar Dash. He's a faculty member in the Department of Aerospace Engineering here at IIT Kharagpur. He is a colleague, but he will be speaking and giving us information broadly over aerospace engineering. So let us get into the discussions. Welcome, Sunil.
Thank you, Jeevan. It's nice for inviting me to this session of discussion.
Yeah, and it's really nice that you agreed to have this thing. So, all right. So my first question is that what is the difference between aerospace engineering and aeronautical engineering?
Yes, I think most of the student will have this curiosity to know about what is the difference between this. Aerospace engineering and aeronautical engineering, the subject matter may overlap for a few, but vastly they are different. Like I'll talk about few differences in broader sense. So aeronautical engineering is mostly towards like dealing with the aircraft, which is within the Earth atmosphere when you're talking about flying vehicles like aircraft or helicopter related to that. But when you talk about aerospace engineering, it is not necessarily within the Earth atmosphere. We can go beyond Earth atmosphere. Okay. So we go to satellites, like we go to the outer space. There are a lot of activities, but we also cover in our studies. And when we include that part, not limiting ourselves to only aircraft engineering perspective, then we go for aerospace engineering. In IIT system, mostly we are offering aerospace engineering. If you talk about 4 IITs like IIT Kharagpur, Kanpur, Madras, and Bombay, in all these 4 IITs, right now we are offering aerospace engineering, not limiting to aeronautical engineering.
So aeronautical engineering is like a subset of aerospace engineering.
Subset of aerospace engineering. Okay. But at the same time, I should also say that they study a lot about aircraft related stuff like aircraft maintenance, aircraft engineering, design, okay, which we may not be covering that extensively.
So it's much more nuts and bolts details regarding the practical aspects of the engineering there.
Yes, in aeronautical engineering. Correct.
All right, good to know. So here in the various departments, we have certain sections within the department. Now, when we were students, most of us did not know about that. When I was, just beginning in my mechanical engineering, I also did not know that there are so many divisions, because mechanical engineering itself was like a specialization of applied physics. On top of that, there was something I did not even know about it. So now that we know, so can you give some idea about some broad sections or divisions within the Department of Aerospace Engineering?
Yes. So for example, like in IIT Kharagpur, we have divided the course curriculum in such a way that there are 4 subdivisions we can have in aerospace engineering. So the first one, which I personally work, like my specialization is aerodynamics. Okay, so then in aerodynamics, there are again different segment, like you can talk about low speed aerodynamics, high speed aerodynamics. Low speed aerodynamics in nutshell, I can say that it deals with the vehicles which are moving at lower speed. High speed we go about similar to the sound speed or more than sound speed, which are talked as high speed aerodynamics. Other than that, the second division what we have is propulsion system. Like when we talk about a vehicle to move, we definitely need an engine or some thruster. So like, for example, if you're talking about aircraft propulsion can happen using jet engine or various type of engine, jet propulsion. Then when you talk about missiles or rocket, so then the propulsion system completely changes. So we have another section where we talk about propulsion mechanism for this moving vehicle. Then the third aspect what we try to study here is structures. Okay, so all these aerial vehicles will have definitely a framework. So those framework, again, how they are constructed, what are the forces they experience, when they are moving in the air at different speed. So with respect to that, we have another domain where we deal with aerostructures. And the fourth one, when we are talking about a vehicle moving from one place to other place, this aerial vehicle, like for example, plane or helicopter, or you can name it. So there, obviously, we need to optimize the trajectory when it is moving from point A to point B, how it is moving. So for that sense, we are having another division, which is called controls and flight mechanics. So these are four major areas that we cover in a BTech course or dual degree course: aerodynamics, propulsion, then aerostructures, then controls and flight mechanics. So these are four subdivisions what we have.
I see. I see. And I believe when one goes into higher studies, one gets to specialize in these various sections also.
Yes. So when the student actually towards their final year, even they can start before that, they tends to have interest in one of the specialization. So they start to do project work, and from there, the project work, they can further continue their higher studies like masters or PhD studies in one of the specialization. Yes.
Right. Okay. So since this is primarily targeted at the students who are, I mean, not in the know-how regarding what kind of things are actually going on, I think it would be a good idea if you can give us some broad overview of the important fundamental courses that are taught,
Okay.
mainly at the first year to third year level, something like that.
Yes.
First year, let us not get into first year because those are common courses.
First year,
But yeah, from second year, third year, what kind of fundamental courses are taught?
Yes. So as like if you talk about being an aerospace engineer, so you need to cover up all these four sub areas, like what you mentioned: aerodynamics, propulsion, then structures, as well as controls. So there are various courses aligned towards this specialized area. So if I talk about aerodynamics first, so we have like courses introduction to aerodynamics, then we have courses like low speed aerodynamics, high speed aerodynamics. Like aerodynamics, if I just want to quickly talk about what is aerodynamics, it's talk about like how a particular object, when it is moving in air, what are the forces, moments experience on the object. Okay, so we try to understand based on its shape, based on its moving speed, all those we cover in these courses in terms of aerodynamics. Then when we talk about this propulsion system, so the propulsion system, there are fundamental courses like aircraft propulsion, then thermodynamic and advanced propulsion systems, where we talk about different type of engines. Okay, starting from jet engine, then we go for turbojet, turboprop. Then at different speed, we can go off like if you talk about very high speed, which are like fighter jet, or talk about the rocket propulsion. So then there are specialized engines like scramjet, ramjet. Those engines we will cover up in advanced courses. So then we go to the third areas, which is like aerostructure. In aerostructure, then we start with the fundamental course like introduction to aerostructure, where we talk about different type of design of the framework of the aircraft. Like for example, there is a fuselage, there is a wing. Okay, so how they are designed and how they are able to sustain huge amount of load when they are flying. The vehicle is flying on air. So what are the forces acting at different location on the wing or on these flying structures? Those we cover in fundamental courses like aerostructures. And then we go for advanced topic in that area, like we go for composite or additive manufacturing. How you can add different materials, like recent ones, advanced materials, to optimize the weight of the structure. Okay, different manufacturing technology also kind of we cover. So then going to the fourth aspect, which is your controls and flight mechanics. So we have like flight dynamics and different control optimization courses, which cover up like how we can move one vehicle from one location to other location suitably. So there are a lot of algorithms that they cover up. So these are some of the fundamentals as well as the additional advanced courses the students can take. There are at the same time, there are a lot of elective courses that we offer specifically in IIT Kharagpur, which are like experimental aerodynamics, experimental propulsion technology. Other than that, the computational aerodynamics, computational fluid mechanics laboratories. There are advanced courses which are also covered in the UG curriculum.
Okay. So this brings back memories. So in my second year, I had actually taken as one of my breadth subjects, Introduction to Aerospace Structures.
Yes.
Very senior professor, Professor P.K. Datta had taught us that course. And
Yeah,
I
yeah.
think that was the first time we had an exposure to the index notation.
Index notation.
So that was hardcore solid mechanics back then.
Correct,
Uh,
correct.
yeah, good
He
memories.
was a very nice professor
Yes,
here.
yes. Yeah.
Yes.
So based on these kinds of various courses that the students have to study, what I would like to ask is like, what in your opinion, uh, I mean, what kind of students based on their skills, temperament, academic interests are best suited for this department? Why I'm asking this is, see, I mean, most of the time, and even when I was a student, what we did was we chose the department based on the counseling brochure, like the rankings which were there for the senior batches. They took for this kind of a rank, they took this department. I have also got this rank, so I am also taking this department. So this is the general procedure. I think many students even now they follow, or they get to hear certain arbitrary bits of information from here and there. They take this thing, but after joining, they realize that they are not at all suitable for the kinds of courses that they have taken. Sometimes students suffer also from a misconception that uh, in the counseling, during the counseling, they get to know that, okay, maybe from rank 1 to so and so computer science fields, and then maybe electronics and electrical, then maybe mechanical, then something like aerospace or something like this, some random ranks. Now, it is not always true, and I mean, not at all true, that just because some department is being filled up by higher ranks, it is more hard than a department which is being filled up by lower ranks. So even though mechanical, aerospace, these are filled up not as by as high a rank as computer science, but the subject matter is still very difficult. So, and it has a certain way of studying, which we all realize as teachers, we all realize it requires a certain bent of mind also. So that is why I'm asking, uh, just because a student has gotten a reasonably good rank doesn't necessarily mean that he has to go into computer science or into mechanical. Maybe he'll be far more suited in aerospace. And similarly, a student who is getting just aerospace does not necessarily mean that he should take up aerospace. Maybe he'll be suitable for something else. So that's why I'm asking, what kind of students, based on their skills, academic interests, they'll be best suited for this department? If you can give some idea about it.
Yes, definitely, Jivan. This is a very nice question. And obviously, student from the first year, when they join IIT or before joining IIT, they have this confusion, which department will be best for my career or best of my interest. Sometimes they are driven by external factors like the
Yes.
seniors, like this thing, like you have mentioned. But at the same time, I must also introduce that what is aerospace engineering, because I did not probably say at the beginning. Aerospace engineering is a interdisciplinary engineering. As you can see from 4 subsections, like it covers of a lot of other engineering aspects and packaging them to a interdisciplinary engineering. So many other institutions, like even in India, or if you talk about abroad, aerospace engineering is a part of mechanical engineering.
Yes.
Okay. So we cover up a lot of areas of mechanical engineering, but not limiting to that. We also cover up a lot of aspect of electrical and electronics engineering. If we talk about when we come to the aircraft controls and trajectory optimization, then there are a lot of areas which includes electronics and electrical communication systems and navigation, radar, sonar, all those aspects are also appear. So it includes a lot of studies from electronics background. When we talk about aerostructures like it is kind of equivalent to if you talk about civil structures or mechanical, solid mechanics, lot of allied areas, similarities are there in aerostructures. Propulsion also a lot of thermodynamics aspect which we cover up in mechanical engineering or civil engineering. So those are also covered. So this is a department where students, if has an interest to join as an interdisciplinary or become an interdisciplinary engineer, that means like if someone wants to really go into an industry where he can use up all this knowledge and parallelly they develop towards it or contributes towards the industry, that is one area. Or if someone wants to go for a higher studies along these lines, should opt for aerospace engineering. So since it is a mixture of 2-3 departments like which I named already. So if one has interest towards any of this department and unfortunately or not able to find a good rank to join electrical or not able to find a good rank to join mechanical, then probably could consider aerospace engineering. Or if someone is really interested for aerospace engineering with a high rank, also we welcome, because they will learn much more than mechanical, electrical. This is a combined interdisciplinary knowledge which we'll offer. At the same time, I must also say that students these days, they are more inclined towards the computer related like AI, ML or other areas, like almost all the departments they are trying to go towards that. But having a core knowledge about the own department is more important. Like that gives you advantage over just knowing the AI, ML type. If you don't study about pure aerodynamics or pure propulsion system, you may not be able to apply the artificial intelligence, machine learning towards like which most of the students these days are driven, or trying to find out how they can fit into a college where they can get this sort of branches. Okay, so aerospace would be much interesting branch if they are really interested to work something on electrical, mechanical related that areas. Yes.
Thank you. Thank you. So this connects us to another thread of question, which is that, see, when the students are joining, they, first of all, they don't know anything about engineering. So this is the situation with most students, unless they happen to come from an engineering type of family, their parents are engineers. I mean, but that number is relatively much fewer. So their knowledge regarding the academics is mostly confined to physics, chemistry, mathematics, and to a certain extent in some schools, biology. So the natural question here is that based on their interests of physics, chemistry, mathematics, which kind of thing would be the most appropriate fit for aerospace engineering? Like if they are good in such and such topics in physics, mathematics, chemistry, maybe, then they would be a perfect fit for aerospace. Is there such a thing? Then maybe certainly
Yes.
one thing is that mechanics within physics, if they're good at it, I mean, there's a good chance that they will be a very good fit in mechanical engineering, in aerospace engineering, in civil engineering, these kinds of things. But beyond that, mechanics, of course, is the obvious answer.
Okay.
But beyond that, maybe thermodynamics, something like that. Can you
Thermodynamics
some
could
idea?
be another areas. Yes, mechanics, like already you have mentioned.
Yes.
There are a lot of mathematics involved in our course curriculum. Like
Yes.
if you talk about controls,
Right.
then flight dynamics, where we try to ask the student to do a lot of coding or a lot of computational work, which involves linear algebra or advanced level of mathematics. So a student having keen interest towards mathematics also a good fit for this particular department. Other than that, if you are talking about if someone is interested about fluid mechanics, because there are two sub branches which I mentioned, aerodynamics and propulsion system, where majorly they deal with fluid mechanics, which many students in their physics they would have covered.
Yes.
So if they're inclined towards that area, also they probably can join. Chemistry, if someone is also interested about chemistry, there are like rocket propulsion and there are a lot of fuel that goes in this aviation industries. So not to large extent, but we still cover up 1 or 2 courses which include this chemical composition. But still, like if someone wants to build a career in this area, like
Perhaps related to combustion systems, something.
combustion systems, yes. So
Okay.
they are also, so chemistry knowledge will be definitely helpful.
Yes.
So PCM and another thing is about biology. Also, you have mentioned few students they have kept biology. So recently, like probably everyone you may have heard about, everyone is talking about drones, and these drones are mostly inspired from biological flying creatures or swimming creatures.
Yes.
Like if someone has studied about birds or insects in depth, probably looking at them how they are flying will also make them interested to study about aerospace engineering. Because a lot of scientists these days are trying to develop small micro aerial vehicles, underwater vehicles. that could be a big opportunity in future. Okay, so even biology people having a biology may be useful in aerospace engineering.
At
Yes.
least in terms of the motivation that,
Yes.
yeah. I want to linger a little bit on what you mentioned regarding the importance of mathematics in aerospace engineering. So from whatever little I know, in aerospace engineering, especially in the aerodynamic side, you have to deal with a lot of high Reynolds number fluid mechanics. And
Yes.
so things like boundary layer theory are like huge applications there. And in the modern context, this is basically applied mathematics.
Yes.
So the higher you go, it is basically applied mathematics.
Yes. Yes.
All the modern developments, I mean, many of the modern developments have actually been done by mathematicians there.
Correct.
In boundary layer theory, especially those things related to uh, asymptotics, like singular perturbation theory, and all these things have been motivated by boundary layer theory as well as have motivated further developments in boundary layer theory. So people so when students are there in their class 11 and 12, probably they don't realize this, but a lot of the things which they study in their calculus, it has a lot of direct applications within the applied mathematics side, as well as the applications of applied mathematics in the engineering sciences. So aerospace engineering is a classic example of this.
Correct.
Absolutely classic
I
example.
agree, completely agree with you, because like I mentioned, in all those four subdivisions, like aerodynamics or propulsion, any you name it, there are a lot of mathematical formulation that student has to learn. Okay, and at the same time, these are like quite interesting in terms, because when we talk something like, if you talk about an engineering student, they try to always find out some numbers and how they calculate the numbers using some equations and all that. And most of the time also we see students are more comfortable telling a concept in terms of the number or in terms of the equation. Yes. So both the ways, like it benefits them when we understand, when they understand these equations better way. And for us, writing a bigger concept using an equation makes us easier. Like if you talk about high Reynolds number flow, how do we define the flow condition region in a three-dimensional space? So for that, if you can define a simplified one-line equation, then that will be easier, so that generic equation can be applied anywhere in the flow domain. So in that sense, mathematics is quite involved in aerospace sector. Aerodynamics or aerostructures. If you talk about structural dynamics, yes, also there are Euler-Bernoulli equation, and there are any higher order equations also which will appear.
Yes.
And in terms of the controls, also there are like guiding principles and trajectory equations, trajectory optimizations. Those also involves
A
lot
huge
of
amount of
mathematics.
linear algebra would be involved there.
Linear algebra and computational work. At the same time, students having an interest towards coding and solver development, they will also get benefited out of this equation when they try to solve this governing equations and all. And there are also well-known Navier-Stokes equation. Probably they will come to know once they join the course, which is $1 billion winner prize, still yet to be claimed. I think then few of them, if they can solve that equation, then they probably. Yes. Yes. Yeah, definitely. I think mathematics is quite involved in this.
Yes, yes. And as you said, I mean, mathematics combined with a lot of programming work.
Yes.
Okay, so how heavy is the course load? Because this is something students are always asking, especially the junior students are always asking, like how heavy is the course load? Will it leave any time for extracurricular activities or maybe even co-curricular activities?
Yep. Yes, course-wise, I must not say it is very heavy, but it will be demanding as long as the student is sincere in the class and coming to the class every day regularly and going through the homework given or the classwork given. Should be all right to cover up. Like it is not very heavy demanding, and there will be definitely a lot of rooms for co-curricular activities. Like if I talk about aerospace engineering department in IIT Kharagpur, we have aero modeling lab. And there are other allied labs like that. So in aero modeling lab, students get involved and they have opportunity to build their own vehicle, on-road vehicle or aerial vehicles like drones or micro aerial vehicles, underwater vehicles. So a lot of small projects students get involved other than solely depending on the course curricula subject matter. Okay, so extra activities they can very well do. And there are a lot of field trips. Sometimes we go to like different DRDO labs. Like recently we have been visited to DRDO labs in Balasore nearby Odisha, and other labs, like sometimes we go to also the Bangalore or IIT Kanpur flight labs. So the student get opportunity to see around other activities, not just limited to studies, practical opportunities also they can get. Lot of areas of advanced research that is also covered in our course curriculum, which is not limited to the textbook, but people or the students need to go through different journal article, talk to the senior students like PhD students or the professors to do this sort of advanced studies along the aerospace division.
Right. So this is regarding the study matter. Now, coming to the all important question regarding jobs. So what kind of core jobs are there for a graduate of the Department of Aerospace Engineering? And I'm not talking only about IIT Kharagpur. In general, for aerospace engineers, what kind of jobs are there? And are they available in India?
Yes. So aerospace engineer, for them, sky is not the limit. Like it is the aerospace,
Yes.
the name itself says. There are a lot of opportunities. If someone wants to go for higher studies, there are various institutions which is available across the globe. We can talk about Texas, Purdue in US, and there are various European universities, various Asian universities also available. So these are for the higher studies. If you talk about jobs like industry related jobs, there are core research areas like we all know about Chandrayaan 3, and we also know about upcoming missions by ISRO. So ISRO is one of the core industry which graduates from aerospace engineering can join. There are other industries like DRDO labs. They have a lot of application in aerospace division. Like I said, aerospace is an interdisciplinary area where graduating student can join to a mechanical engineering, electrical engineering, if not the core aerospace engineering. There are other core aerospace companies like Airbus is there, Boeing, Collins Aerospace, Rolls-Royce, Land Rover, Jaguar, which are allied companies, not solely related to the aerospace, but they also can join in these companies. There are more companies. If we try to find out a list, it will be more than 50 probably.
Okay.
So there are
Okay,
a lot
that
of
is good to know. That is good to know. So what you mentioned, I mean, it kind of made me think about something. So, for example, a student who is studying mechanical engineering right now in his undergraduate days, and probably he develops a more interest, or maybe he had this kind of an interest to go into some kind of aerospace work from his childhood. Many of us have. So, is it possible for him or her to later on specialize in aerospace engineering? I think we have heard of some examples like this, right? So undergraduate in mechanical engineering, but master specialization in aerospace. I think it is possible, right? Can you give some
it is
idea?
quite possible. Yes, it is quite possible. Like because why it is so it may not be so difficult, but it is quite doable. Like a student coming from mechanical background or electrical background can further continue his or her studies in aerospace engineering because they already are introduced to the fundamental courses in their core engineering department itself, mechanical or electrical. And in aerospace engineering, they will be covering up more applied aspect of those courses. So it is quite doable. And one of the prominent example, if we talk about, is Mr. S. Somnath, who is currently chairperson in ISRO. He is also a mechanical engineer, but later on converted to aerospace engineering from IISc Bangalore. So that is quite doable. There are a lot of other examples also which we can find. So students have been doing in our department also. We have seen people, particularly the undergraduate students who are from mechanical, they're joining the master's program in our department or PhD program in our department in aerospace. They have done their previous studies in mechanical, electrical, civil, but they are joining aerospace engineering for the higher studies.
See. So since this video is meant for absolutely junior students who have no idea, can you just, little bit elaborate on this answer that in the industry, for what specific kind of code work, an aerospace engineer would be absolutely indispensable, like what he can do, nobody else can do. Is there something like that?
Okay, so aerospace engineering, the subject matter what they cover will be more applied towards the aerospace industry.
Right.
Definitely, mechanical graduate or electrical graduate may not able to understand the aerospace industry that clear.
Certain aspects of it,
like if you talk about aerostructure, if you talk about aerostructure, for example. So the aircraft wings are specially made and they are made up of thin material, thin aerostructures. And the design is such a way that it takes the load uniformly while it is flying on air. It may be difficult for a mechanical student to design those structures. Okay. And at the same time, if you talk about the fluid mechanics around the wing, it will be more easier for an aerospace engineer than the mechanical engineer, because aerospace engineer, mostly we discuss about a different flow regime where the flow speed is comparatively higher.
Yes.
And if you talk about mechanical or civil, the flow speed is relatively small. Okay, so those areas where if you talk about pure aerospace industry, then aerospace engineering students will be more suited than other branches. Okay, but at the same time, I must also say other way, like aerospace engineer, they can very well contribute to this mechanical industry or electrical industry because the knowledge is somewhat overlapping in certain subject matter. So they can very well develop themselves towards this
So
mechanical.
perhaps in the industries building turbo machinery, these kinds of things.
Yep, turbo machinery is.
Yes. Okay. So this is a question which everyone's minds nowadays, that aerospace is a very classical discipline. Now more than 100 years or so. So in such a well-developed, very mature, sophisticated technology-wise department or field, what do you think would be the impact of artificial intelligence in the coming years?
Okay. Yeah, artificial intelligence, already we are seeing it is taking a turn on all the areas of engineering, not necessarily engineering, it is almost in everywhere.
Everything.
Yes. So actually, artificial intelligence in a way is a good addition to the stream. This is my personal perspective. Because think about problem in aerodynamics or aerostructures. When we try to find a solution, like if you want to move a vehicle in a certain way, in a certain atmospheric condition. Okay, so there are a lot of simulations, probably computational simulation we have to do or experiments we need to do. But with the use of artificial intelligence, many solutions which is already available to us, using those available solutions, we can train the data set and probably can find a solution in a much effective way without trying to do a high-end computational or high expensive experiments. We can probably get the solution much faster and much cheaper way. So in a way, this is a good addition to the aerospace stream. And we are already using it in different areas. Like already we have like aerospace structure optimization or trajectory optimization. Those areas, AI, ML are already introduced in the courses. Okay, and there are specific, if a student wants to take a part of his or her studies in AI, ML along with the aerospace, so that opportunity is also available, aerospace, and can take a minor in AI, ML, artificial intelligence, machine learning, where they will be able to study somewhat, may not be complete in depth, but some courses related to AI, ML, they can also study. Okay.
Yeah, on this note, and correct me if I'm wrong,
Yeah.
I think It is because we have such a mature technology within aerospace that AI, ML, artificial intelligence, and machine learning can have such a great impact. Because without the base data set, which would be available from already existing very sophisticated experiments,
Yep.
you cannot have the application of AI, ML. You cannot apply it in thin air.
Absolutely, I agree with you, Jiva.
Yes, so
So
you first have to have the data sets, and those data sets are to be generated from the classical experiments itself.
So like you have already mentioned, the aerospace industry is more than 100 years old.
Yes.
Like the flights are there about 100 years plus.
Yes.
And the curiosity is there much before, like you talk
Yes.
about
Yes.
Leonardo da Vinci.
Yes.
A lot of data set is available, a lot of simulation work, experimental work, even industry, they have established their own data set. So since they are available, now prediction using artificial intelligence or machine learning, it seems to be doable. And many times it is accurate enough. We don't have to do many experiments. But yes, at the same time, if you want to venture into a completely new area, or little bit having advanced trouble set or the boundary condition is little different, then probably the AI/ML may not give us accurate solution. So wherever the data set is available, the prediction is possible, which we're taking the advantage at this stage. Yes.
Right. So which also means that in the future, we will still very much need proper graduates of aerospace engineering to do the actual work on which AI ML can be applied.
Correct, correct. Only AI/ML cannot sustain without the core engineering. It is true for not
Yes.
the aerospace. It is true for all the areas of engineering. So there has to be the core areas of work, research or industry work, on top of which the solution can be optimized using the AI or ML.
And on the flip side, if we think about it, a graduate from aerospace engineering, if he can somehow have some kind of an extra specialization or coursework or an extra know-how in this direction of artificial intelligence and machine learning, then he will be tremendously valuable to the modern industry, is it not?
Absolutely, yes. Having the knowledge of both the areas, having the core as well as the AI/ML, that make the candidate a best fit for most of the industries.
The golden combination.
Golden combination.
Yes.
And these are high-paying job nowadays, like if you talk about, yes.
So I think this this ties into our next question, which is that in addition to the core expertise, which is there in the department, which you guys as professors will definitely train the students. In addition to this, what kind of other soft skills or extra skills can the students develop? Certainly one aspect is programming itself, which is, I would say, a classical part of aerospace engineering. In the third decade of the 21st century, programming is a classical subject, classical topic. So in addition to that, anything else?
Core engineering branches definitely need the candidates, like the graduates, to go to the field where they may need to explore themselves to the machines. Okay, so the production line or even in the maintenance sector. So the students should have interest if they would really want to join aerospace industries, not limiting themselves to the high white collar job where they sit in the computer room. Other than that, they must need to prepare themselves for visiting the production line or maintenance line where they need to spend some time, like doing real engineering job. So engineering in nutshell, we can say that we go to the field and try to fix something, right? That's kind of many people have this observation. We are like high paid mechanic, right? So those sort of, if students has to be mentally prepared or have the willingness towards doing this sort of industry where it demands manufacturing and getting involved into lot of machines. Okay, so not necessarily only working on the computers, but exposing themselves to various experimental sector or various production lines. So these sort of jobs, if they are interested, they should join us.
Right. So speaking about jobs, I think in addition, we have been talking about the core areas, but in addition to that, we have seen that
Yes.
so just like in other departments, our aerospace engineering graduates, they also go into various different kinds of non-core areas like finance, consultancy, these kinds of things. So if a student is, gets interested, gets his interest away from the core departments, core departmental things, that also is a career opportunity very much. Uh, Especially those kinds of things always need smart people, and aerospace engineering does have smart people always. So that is always there. So
Yes, yes.
yeah. So this was just a comment. My final thing is, uh, so I have been asking you a lot of questions. From your side, do you have any message to students who would be joining aerospace engineering? So especially now, many of the institutes, we are doing away with the department change thing. So when they join a particular department in their first year, it is guaranteed that this is going to be their career. So do you have any message for them? So
Yeah. So I would like to give a general message, not limiting myself to the aerospace engineering.
okay.
So if you are getting any branch which is not of your choice, sometimes the students who are joining IIT program, BTech or the dual degree program, they are not uh, aware of completely. They may be knowing something about the particular department, but they may not be knowing completely what they're going to study in the course of like 4 years or 5 years span. So keep yourself open to the knowledge, because knowledge is always valuable, and whatever you learn is definitely going to help you, being it a core area or non-core area, whichever is your interest. Because we have seen people joining aerospace industry and later on working in computer segment or banking or any other areas.
Yes.
So they can very well change to other interest of yours in future. But at the same time, people working in aerospace industry also going in terms of the academics or in research industries. So keep yourself open to whichever departments you get. All the branches are equally important, and there are huge job market as well as higher study opportunities. And if they are not uh, closing themselves that, okay, I did not get computer science, that was my keen interest because that's the job market, and I am going to join aerospace industry, what is going to happen? This is not my first choice. So don't think about that, because if you study in aerospace industry or if you study in aerospace engineering department, there are a lot of opportunity for you to also do coding, or lot of opportunity to study whatever branches of your choice was. Okay, because this is an interdisciplinary engineering field. So you can definitely can contribute, and but you need to be at the same time sincere with your studies. Keep yourself open, and best wishes to all those students who are going to join IIT for their studies in the upcoming semester.
Thank you. Thank you, Sunil.
Thank
Thank you very much for your valuable message and for answering the questions. So some of the things even I was not aware. So thanks a lot for opening our eyes.
thank you.
Wonderful talking to
Thank you
you.
for inviting me.
Yeah. So, all right.
Thank
Thank you very
you.
much.
Bye.
And all the best to the students who will be joining aerospace engineering.